Okay, now you're going to watch an Amoeba Sisters here in a second on sex-linked traits. It will also explain the genetic disorder hemophilia. Now, while you're watching this video, I want you to think of the following three questions. How do you write a genotype for a female? How do you write the genotype for a male? And how do you do Punnett squares when you do sex-linked trait problems?
Wait.
Would you like to know one of the most underappreciated pieces of cytoplasm out there? Platelets. We take for granted the function of our platelets, which are fragments of cytoplasm that help stop us from bleeding. They help our blood clot when we get hurt. But there is a disorder called hemophilia that can affect those platelets because special clotting factor proteins that are needed to work with the platelets may not work correctly. So even a basic cut could be dangerous for people with hemophilia because they could bleed continuously. We have many treatments for the symptoms of hemophilia, and this has greatly improved outcomes with this disorder, although it wasn't always that way. Hemophilia is a sex-linked recessive trait, which means it's different from the basic Mendelian genetic problems. What do I mean by that? Well, we still use the terms dominant and recessive for alleles, but this time, because it's sex-linked, the alleles are on sex chromosomes. This is the case with sex-linked traits. So what is a sex chromosome? Well, recall that humans have 46 chromosomes. Chromosomes are made up of DNA and protein, and they contain your genes. Well, 2 of your 46 chromosomes, they are called the sex chromosomes. In a karyotype, it is usually the last 2 chromosomes that are the sex chromosomes. The sex chromosomes are called X and Y chromosomes, but it has nothing to do with the shape of the chromosome. That's always kind of confusing, but please don't think that Y chromosomes are shaped like a Y and X chromosomes are shaped like an X. This used to always confuse me. It has nothing to do with their name. The reason they got their name is actually kind of interesting, so to the Google for that. Everyone has an X chromosome, but if you have another X chromosome, meaning you have 2 X chromosomes, you are female. And if you have a Y chromosome, meaning you have an X and a Y chromosome, you are male. There are also genetic disorders where you can have extra copies of sex chromosomes, but we will not go into that in this clip. Sex-linked traits are traits that are specifically on the sex chromosomes. Most sex-linked traits tend to be on the X chromosome because it is larger than the Y chromosome and it contains more genes than the Y chromosome. The disorder hemophilia is like this. Now we will use the letter capital H to represent an allele for having normal blood clotting function and a letter lowercase h to represent an allele for having hemophilia. Hemophilia is a sex-linked recessive disorder, which is why it's being represented by a lowercase letter h. Only it must be placed on the sex chromosome as a superscript, like an exponent. A woman that does not have hemophilia could have the genotype X big H, or X big H, X little h. Because as long as she's got at least one dominant allele, that dominating allele will be what shows. So no hemophilia, since again, hemophilia is a recessive sex-linked disorder. The only way for her to have hemophilia would be the genotype X little h, because only when there is no dominant present will that recessive show up, at least in this type of trait. Now for a male to not have hemophilia, his genotype would have to be X big H, Y. Notice how I did not put anything on the Y chromosome. Again, most sex-linked traits are on the X chromosome. If he has the genotype X little h, Y, then he has hemophilia. He doesn't have 2 X chromosomes, so he cannot be a carrier. So let's say that 2 people that do not have hemophilia have children. However, let's say that the woman is a carrier. That means she is heterozygous. How do you do a sex-linked Punnett square cross for this kind of trait? Step 1. Identify the genotypes of the parents. So the mother was a carrier. She is X big H, X little h. She does not have hemophilia because of that dominant allele present, but she is a carrier. The male, if he does not have hemophilia, well, he must be X big HY. There's no other option for him. Step 2. Place one parent on the top, outside of the square like this, and place the other parent on the left, outside of the square like this. Step 3. Cross them. For formatting purposes, place X chromosomes before Y, and you also write any sex chromosomes with dominant letters first. The results you get in the squares would be the offspring, the babies. The genotype ratio could be written out like this. The phenotype ratio, remember that these are the observable traits, can be written out that there is a 75% chance that the child will be born without hemophilia and a 25% chance that a child would have hemophilia for this boy here. You could also make this a ratio, so 3:1. Notice that in this type of example of a sex-linked recessive disorder, males are more likely to inherit this disorder because there is only one X chromosome present. This is true for many other sex-linked recessive disorders, such as colorblindness. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.
Okay, so for this one, we will use H's like they did in the video. So this would be normal blood clotting. Normal blood clotting. Whereas if you have the recessive allele, you would have hemophilia. So a female does not have hemophilia. So we have to do her sex chromosomes first, right? She does not have it, and she's homozygous. So that means she has to be big H, big H. Now the male does have hemophilia, so he would have a little h. Now what are the chances of having a child with hemophilia? So set up the cross. Capital letters first, alphabetical, just as always. Okay, so what are the chances of having a child with hemophilia? You always have to make sure that you answer the question. There is a 0% chance. Now, would their female offspring need to worry about any possible children they would have? So if you look up here, the female offspring, so if these females have children, they would have to worry because they are both carriers. Both females are heterozygous for hemophilia, which means they can potentially pass on the trait, okay, because they are carriers for it. All right, hope that helps. Now answer the couple questions that